Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So I'm going to talk about the area between the curve and intersecting line. I'm going to just a follow-up of the previous video. I'm going to solve one more example here. Now we'll try and solve it together, all right? So before I proceed, don't forget to like, share, and subscribe. If you've not clicked the notification bell, please do so that when I post new videos, you'll be the first person to know. All right, so let's solve this together. Okay. So let's say we have this question here, and you're told to find the area enclosed between the curve y is equal to x cubed and the straight line y is equal to x. So you were told to do this. So we can draw the curve. Okay. So we have this here. Right there. Okay. And we have a curve, y is equal to x cubed. So y equal to x cubed, the curve will be something like this. So please, if you've forgotten how to sketch, please go back and have a look. So that will be the curve, y is equal to x cubed. Or should I use a different pen then? Let me use a purple for this. Okay, so we have that. Then the next one, we are having y is equal to x. So I taught you the y equal to x. So it basically means it's a straight line that's passing through the curve. Okay. So we have, I'm going to use, let me use red line to do this. So we have straight line. The y is equal to x. Okay. So that's a y equal to x straight line. Okay, and we have, this is y is equal to x. Okay, because the intercept is 0, so that means it's passing through the origin. Then we're now going to draw the curve. We're told that we have a curve here. So we have this one. Okay. Okay, so that is it. So we have that, so it looks like that. Wow, this will look like this. Good. All right, so then that will be the y is equal to x cubed. So that will be y will be equal to what? X cubed. And we're told to find the area enclosed by this. So we're looking for the area of this part here. Area enclosed here and area enclosed here. All right, good. So let's go with the first step. So the first step, I told you, step one, is that at point of intersection, so I told you at point of intersection, y1 is equal to y2. So that means the line and the curve will be equal to each other. So that means what we are saying is that at this point here, so at this point of intersection here, and the point of intersection here, they will be what? Equal to each other. So we're trying to find out what is the x value for each of this. Okay? So that means at this point, y equals to x cubed will be equal to y equal to x. So that means x cubed will be equal to x, okay? You take this to the other side, so x cubed minus x will be equal to 0. Then you factorize this, so x is gonna give us x squared minus 1 equal to 0. Then we can break down x squared minus 1 to be difference of 2 squares. So because remember I told you a squared minus b squared is equal to a minus b and a plus b, okay? So it's going to be a minus b and a plus b, all right? So, and I can also write this as x squared minus 1 squared because it's a form of difference of 2 squared. So that means it's going to give us x minus 1 and x plus 1. So I can rewrite this again as x into brackets, x minus 1 and x plus 1 will be equal to what? 0. So then we can now have 3 solutions for this. So it means that x is equal to what? 0. So x will be equal to 0. X minus 1 will be equal to 0. Or x plus 1 will be equal to 0. So therefore, x will be equal to 0 already. You take minus 1 to the other side, it becomes 1. And take 1 to the other side, become minus 1. So these are the 3 possible answers for this. So x will be equal to 0, x will be equal to minus 1, and plus 1, all right? So that means for this now, so that means we have, see the intersection here? So it's another intersection at this point here. So you can see in this intersection, we have 3. So this intersection here, so I'll use another colors to bring it out. So this intersection here is 0. This intersection here is a 1. And the intersection here is minus 1. Okay? So, all right. So let's copy this again so that we can bring it further down. Okay, so let's copy that. So copy. Then I'll take it all the way to step 2. All right? So somewhere here and put it all the way down here. Okay? So now, so step 2, we then have to rewrite this with each of the what? Limits. So that means you can see that we have several limits here from 1 to minus 1. So for the curve, the limits we are having there is from 1 to minus 1. Okay, so step 2, the limit we have there. All right, so step 2, the limit we are having. So for the curve now, we're going to be looking between 1 and minus 1. For the curve of y is equal to x cubed. And also for the line, we're going to be looking same thing between 1 and minus 1 for y will be equal to x. Now, but we need to break it down. That's the reason why I brought down this for step 3. Now we need to look at this carefully, all right? So now let's assume, let's remove this green part and look at it more critically. So I can break this down, okay, into 2 graphs. So I can see between 0 and 1, and I can see between 0 and -1. So that means in order to get this, I can look at 0 and 1. So let me see if I can remove the green parts. No. If I can remove just the green parts. Is that possible? It's going to be a bit difficult. So, but let's just use, let's break it. So let's look at the 0 and 1. So the 0 and 1, we're going to be having, so we have something like this. We have the red line, okay? We have the red line. Okay, are you seeing it? Then we now had the purple curve. Are you seeing that? Then we now had so let me put this one here, okay? The straight line here. But this was the black, okay? And then we now had the blue curve, the purple curve here. We had a purple curve here, okay? And so I'm trying to bring the first one between 0 and 1. So this is 0 and this is 1. Are you seeing it? Good. Then the second one, we can see between 0 and -1. So between 0 and -1, you can also see that we have something similar. Okay, we have the line here, or the black one, okay? Then we have the red one as well. Okay, we have the red one. Then we have the black dots as well. Somewhere here. And this was 0, and this was -1. Then we also had the purple curve here from this point all the way down here. Good. Are you seeing it? So now let's look at it more critically, right? So that means let's start with the first one between 0 and 1. Now, if you integrate the red one, that is y equal to x between 0 and 1. So the red one, so we integrate y with the red one. So we want to integrate y equal to x, that's the red one, between 0 and 1. So that means it's going to give us all the way from that. Remember, it's give you from the curve all the way to the x-axis, right? So it's going to give us all the way from this point all the way down here. Now, if we integrate the purple curve, y equal to between 1 and 0, the x cubed, which is the curve, like I said, is going to give you up to the x-axis. So it's going to give us all this place. Are you seeing it? Up to the x-axis. But we're not looking for this. We're looking for in the middle here, the green one. We're looking for this green one here, this space here. Okay? That's the space we're looking for. We're looking for this space here. Are you seeing it? And the only way to get it, because if all this is the red one and this is the blue one, so that means if we subtract both of them, the red one from the purple one is going to give us what? The space, the green space here. Now let's go to the one below now. So we're going to have the red one. So you can see the red one here. So if we now start with the red one as well, so we're integrating the line, which is the red one, x. Now this time between 0 and -1. So 0 is the upper limit, and -1 is going to be the lower limit. It's going to give us what? Everything we have here. Are you seeing it? Because it's going to be from that curve up to the x-axis. Are you seeing it? Now, and if we integrate the purple one, which is between 0 and 1, x cubed, is going to give us which part? From this part up to the x-axis. Are you seeing it? It's going to give us this part here. But we're not looking for that part. We're looking for the green one, which is what? We're looking for this side. Are you seeing it? And how do you get it? Is that you have to minus this one from the red one, from the purple one. So you minus the purple one from the red one. Is that okay? Then, when we are done with both of them, now to get it, so that means we have, this is the first one, and this is the second one. So this is going to give us the area for each of them. Now, to get the total area, then we're going to add them together. Are you seeing it? So that's the reason why I always say, to be sure, drawing the graph or sketching the graph is not necessary, but it is going to be way, way easier if you can sketch it so that you can be very, very sure of what you're drawing. All right, so let's go straight to step 4, all right, and solve this now. So step 4. So what we're going to do, I'm going to break it up. So I'm going to first solve the first part here, all right, between 0 and 1. Then I'm going to solve between 0 and -1 section and get it differently. All right, so let's start with 0 and 1. So it's 1 and 0 and 1, all right? So we're going to start with that one. So we have this one, 1, 0. We have x, okay? And we have minus exactly the same thing, but this time we're going to have it for cubic. So 1, 0, and x cubed. Are you seeing it? So that means we're going to solve them individually, and then we're going to get an answer for that. So let's solve the red one, okay? So the red one now is going to be, we're going to integrate that. So it's going to become x. Remember, there's 1 on top of this. It's going to be plus 1, 2 divided by 2 between 1 and 0 minus. The purple one is going to be the same thing, but this time it's going to be x. 3 plus 1 will give you 4 divided by 4 between 1 and what? 0. Okay? Now, as usual, for the red one, which was the line, what do? You substitute 1, minus 1, you substitute 0. So it's going to give us 1 squared all over 2 minus, you put 0. So it's going to give us 0 squared divided by what? 2. All right? And when you solve this together, it's going to give you what? Half. Minus, minus. All right? So let's solve the purple one now. So the same thing, you put in 1 and you get an answer, and you subtract when you put in 0. So it's going to give you 1 raised to the power 4 divided by 4 minus 0 raised to the power 4 divided by 4. And this is going to give, when you press your calculator, it's going to give you 1 over 4. Okay? So, and this is going to be the final answer, will be 1 over 2. 1 over 2 minus 1 over 4, and that will give you what? 1 over 4 units squared. Okay, it'll give you 1 over 4 units squared. Now we're done with that, so let's go to the next one. We're going to pick between the next one, 0 and -1. So we're going to pick between 0 and -1 now. So we'll start with the red one. So we're going to the second part now. So we're picking between x is 0, -1, minus, we'll now do the purple one as well. And that will give us between what? 0 and same -1. Okay? 0 and -1, and x raised to the power what? 3. So let's solve this now. So I'm going to start with the red one. So we're going to we'll integrate that. So it's going to be, you add 1 to the power. So it's going to give you x raised to the power what? 2 divided by 2. Then 0 and -1 minus, we do the purple one. So it's going to become x. 3 plus 1 will give you 4 divided by 4. And that will give you 0 and what? Minus 1. Okay. Then we'll now solve the red one. So you're substituting 0 minus 1, substituting minus 1. So it's going to give you 0 squared divided by 2 minus 1 all squared divided by 2. Okay. Then when you do that, so when you press that in your calculator, it should give you minus 1 over 2. Now we're subtracting, right? So we're going to subtract this, we're going to subtract this. Now let's do the purple one as well. For the purple one, you're substituting 0, minus 1, you're substituting minus 1. So it's going to give you, into bracket, 0 raised to the power 4 divided by 4 minus 1 substituting minus 1 minus 1 raised to the power 4 divided by what? 4. Then when you put this, it's going to give you a minus half. So it's going to become minus 1 over what? 4. So minus times minus will give you plus, which will now become, when you press the calculator, minus half plus 1 over 4 will give you minus 1 over 4. So like I told you, you can't have negative signs. Does that make sense? You can't have negative signs, so it's going to become 1 over 4 units squared. 1 over 4 units squared. All right, so we're done with that. But we need to get the total area. So the total area, you have to what? Add both of them together. So you have to add this plus that. So let's add them now. So step 5, which is the final one. Step 5, the total area will be equal to 1 over 4 plus 1 over 4, and that will equal to 1 over 2 units what? Squared. And that will be the answer for that. Okay, so that will be that. I hope this was helpful. So basically, you get a point of intersection. When you've done that, you now you now try to analyze it, break it into smaller areas to see the parts you're interested in. You subtract, then you add depending, then you now do it. You integrate it as normal. You do definite integration, then you get your final answer there. And you add that, and that will give you that. So, and that will be the answer for that. All right, so the next one, we're going to go to the area between two curves now. All right, how do we get to the area between two curves? And like I said, always try to subscribe and click the notification bell so that when I post new videos, you'll be the first person to know. All right, I'll see you. So we're going to talk about area between two curves, and then we'll now move on from there to see how do we find the equation of a curve from its derivatives. All right. All right, so I'll see you, and I'll see you in the next video. See you soon.